Hi, I'm Teacher Michael again, and welcome to Science 9, 4th Quarter, Week 7, Heat Engines and Thermal Efficiency. Heat Engines and Thermal Efficiency. Work requires an amount of energy, so we need energy to perform work. This energy can be of different forms. So yung energy na pwede natin gamitin to perform work ay pwedeng manggaling sa different forms. It includes mechanical energy. If you still remember, we have the two types of mechanical energy. We have kinetic energy and potential energy. That mechanical energy can be used to perform work. Chemical energy also can be a source to perform work. We also have electrical energy and thermal energy. So those are the kind of energy that can be used to perform work. Sometimes, energy needs to be converted from one form to another in order to make work. Most instances or some instances, in order for us to perform work, we have to convert first one energy to another form of energy. One such object that allows us to produce mechanical work from a type of energy is called an engine. So there is what we call engine. This engine is able to perform work or to perform mechanical work through the use of energy. If the energy that was used to perform work was thermal energy or heat, then the engine is called heat engine. So there is what we call heat engine. From the word itself, heat. This heat engine is able to perform work using a kind of energy that is what we call thermal energy. So dun niya makukuha yung heat na kailangan niya para makapag-perform ng work. So that is what we call heat engine. To perform work, heat is taken in by the engine from a heat source, also called the high temperature reservoir. So for a heat engine to perform work, kailangan syempre ng heat. So saan niya makukuha yung heat na yon? So meron siyang tinatawag na high temperature reservoir, wherein the heat engine gets its heat or gets the heat that is needed to perform work. The energy absorbed by the heat engine is used to perform useful work. So, the energy that is being absorbed by the heat engine from the high temperature reservoir will be used to perform useful work. However, not all of the heat absorbed by the engine can be converted into useful work. Pero hindi lahat ng na-absorb na heat mula dun sa high temperature reservoir ni heat engine, hindi lahat dun ay magiging work. There will always be a portion of the heat that will be lost as a result of other interaction like friction. Some of the heat or most of the heat na inabsorb ni heat engine mula sa high temperature reservoir will be lost. Ito ay resulta ng other interaction like friction. So yung tinatawag na heat that will be lost, the lost heat is called what we call the waste heat. Okay, so meron siyang yung init na na-absorb niya at hindi niya nagamit to perform work. Ang tawag doon ay waste heat. This waste heat goes to the low temperature reservoir or the heat sink of the engine. So, ang heat engine, aside from the high temperature reservoir, meron siyang low temperature reservoir kung saan yung heat na hindi niya nagamit na tinatawag na waste heat ay doon mapupunta. Okay? So, those reservoir or it could be a heat sink of an heat engine. The energy converted as useful mechanical work is equal to the difference in the heat input from high temperature reservoir and the heat output that was received by the low temperature reservoir. So para malaman yung useful mechanical work ng isang heat engine, what we're going to do is to know the amount of heat input, yung na-absorb na heat, ma-minus lang doon sa wasted heat or doon sa heat na na-removed or heat na napunta doon sa low temperature reservoir. A heat engine allows us to use heat to perform work. So that's the function of the heat engine. Kailangan niya ng heat from the thermal energy para makapag-perform ng work. Which of the following objects below can be considered a heat engine? Write the letter of all possible answers. So which among of these objects can be considered a heat engine? Wherein, again, heat engine is used to heat to perform work. So kailangan niya ng init para gumalaw siya, para umandar siya, para mag-operate siya. Is it letter H, letter E, letter A? Is it letter T, W, O, R, or is it letter K? So you can write all the possible answers. Did you get the right answer? So these are the possible answers. We have H, R, and K. These are the heat engines. So meaning to say, those vehicles have heat engines wherein their heat engines are able to use heat to perform work. So they use heat engine for this vehicle to perform work, for this vehicle to move, for this vehicle to operate. Okay, like the truck, so the steam train, the airplane. So they have heat engine, or they were able to use heat to perform work. Iron is not an example of heat engine because it uses electrical energy para uminit siya. Okay? Ito naman, it uses mechanical energy para gumalaw siya. Ito naman, it uses electrical energy para umikot siya. This one, candle, it uses chemical energy. At kapag siya ay sinindihan, thermal energy. This one is a power plant. It uses kind of energy to produce electricity. So again, heat engine, it uses thermal energy para mag-perform ng work. So meaning to say, from thermal energy to become mechanical energy. So what is heat engine? A heat engine is a device which converts thermal energy to mechanical energy. So again, this heat engine converts thermal energy, heat, to mechanical energy. So that mechanical energy is the work done. A very important component of heat engine then is that high temperatures are involved. In one round of a cycle, the system is heated, at another is cooled. So in heat engine, if there's a high temperature source, that is the hot source, and there is what we call the cold sink or the low temperature source or the low temperature reservoir. We have the heat input, yung init na nilagay sa heat engine para makapag-perform ng work. Tapos, meron siyang cold sink kung saan yung mga heat na hindi nagamit para maging work ay doon mapupunta. So, meron tayong heat output. Three things happens in a full cycle of heat engine. Number one, heat is added. So, papasok si heat. So, heat is being added. It is an input heat which is relatively high temperature. So, for a certain heat engine to work or to produce work, kailangan niya ng heat. At dapat yung heat na panggagalingan nun o yung source sa panggagalingan nun ay dapat high temperature para makuhanan niya ng heat o ng init. some of that energy from that input heat is used to do work. So once heat is added from the hot source, that heat will be transformed or will be converted to work by the heat engine. But most or the rest of the heat is removed at a relatively cold temperature. But most of the heat will not become work. Most of the heat will become heat output or mapupunta siya doon sa cold sink. Yun yung tinatawag nating waste heat. Okay? So this is the diagram of a engine. Ito yung engine ng isang sasakyan. So meron siyang fuel, gas. So that will be the source of the heat kasi eventually yung gas ay i-burn or magkakaroon ng combustion of fuel. That combustion of fuel will be the source of the heat needed by the heat engine to perform work. But most of the heat from that combusted fuel will not be converted into work, but rather it will be exhausted or it will be removed. A common type of heat engine is called the combustion engine. In a combustion engine, heat is produced using a combustion process, which in turn makes use of fuel and an oxidizer for that fuel like air. So there is what we call combustion engine. Gumagamit siya ng fuel. And that fuel will be combusted or will be burned para maging source ng tinatawag ng init. At para gumana yung heat engine. Kasi yung init na yun ang gagamitin niya to perform work. There are two classes of combustion engines. We have the external combustion engine. So, in external combustion engine, the burning of fuel takes place outside the engine. So, yung pag-combust o yung pagsunog ng fuel ay nangyayari sa labas ng engine. Example nun ay steam piston engine and the atmosphere. So, yung steam piston engine na to, itong ginagamit sa mga steam train or steam engine train. So, they use, the fuel is being combusted outside the engine. So, that is the external combustion engine. Meron naman tayong tinatawag na internal combustion engine wherein the burning of fuels takes place inside the cylinder or turbine engine. Example nun ay yung gasoline or diesel engine in our human body. So, this is an example of gasoline engine. Ito yung nakikita o nasa loob ng mga sasakyan karamihan. Sa mga car, sa truck, sa mga motor. They have this gasoline engine. So, they use fuel. The fuel is being burned inside the engine. Okay, so that burned fuel will be a source of the heat and that heat will be converted into work. But most of the heat is not converted to work but rather will become exhausted. Most automobiles ay mga sasakyan natin makes use of either a diesel engine or gasoline engine. So, gumagamit sila ng diesel engine o yung gasoline engine. In the case of gasoline engines, ito yung gasoline engines. They have 4 cylinders. Ito yung mga cylinder nila. 1, 2, 3, 4. And each cylinder, meron siyang tinatawag na mga piston. Yung mga piston, yun yung umaakyat, yun yung gumagalaw taas-baba. Those are the piston. Okay? And each piston undergoes a series of 4 movements or 4 strokes. So, bawat piston, meron silang 4 na stroke. Okay? That's the reason why the engine works. So, what are the 4-stroke or 4-stroke cycle in a gasoline engine? Okay, so these are the 4-stroke cycle in a gasoline engine. Number 1 is the intake stroke. The intake valve opens, allowing the cylinder to receive the fuel-air mixture as the piston moves downward. So, in intake stroke. Sa intake stroke, si valve ay magbubukas. So, the fuel now will move in or will intake or will take in. So, kaya nga siya intake. So, that's the reason why si piston ngayon ay bababa because of the moving in of the fuel mixture. Now, once there's now a fuel inside, number 2 is what we call the compression stroke. The piston moves up, compressing the fuel air mixture. This time, since pumasok na ngayon si fuel air or the fuel, so sasara ngayon si valve. Then, after moving down, in compression stroke, the piston moves up, wherein it compresses the fuel inside. Iko-compress ngayon yung fuel. So that is the compression stroke. Next is the power stroke. The spark plug at the top of the cylinder. So merong spark plug doon sa top ng cylinder. Ito yun. Yan. That's the spark plug. Causes the mixture to ignite and combust, making its temperature high. With this increase in temperature, the pressure inside the cylinder increases, causing the piston to go down and perform mechanical work. So, nag-compress siya. Because of the compression, merong spark plug dun sa taas. Kaya siya tinawag na spark plug kasi nag-i-ignite siya. Okay? Sumisindi siya. Pag sumindi siya, masusunog ngayon yung fuel. Okay, sa loob. Making the temperature inside higher. And also making the pressure inside higher. Okay, so that's the reason why the piston now will move down. Will go down again. And that's the reason why the piston will do more work. Okay, so that's the combustion. Nasunog na yung fuel. Then the last stroke is what we call the exhaust stroke. The combusted gases are pushed out of the open exhaust valve through an upward motion on the piston. The intake valves open again and the cycle repeats. Okay, so in the exhaust stroke, this time, aakit naman ngayon si piston, o-open ngayon si exhaust. Okay, may valve naman na mag-open for the exhaustion of the gas. Okay, na-burn kanina, i-exhaust ngayon yung na-burn na gas. Okay, so that's the exhaust stroke. So those are the 4-stroke in cycle or 4-stroke cycle in a gasoline engine. So let us take a look in this picture for us to review again how the 4 strokes happen. So that's the intake. The fuel take in, compression, i-compress yung fuel. So ayun, mag-i-ignite, there's a power combustion, then mag-i-exhaust. Okay, so intake again, compression, power, combustion of the fuel, baburn siya, tapos exhaust. Intake again of the fuel, i-compress, mag-i-ignite yung spark plug, high temperature, so it will now do work, then some of the heat will become exhausted, or the gas will become exhausted. So those are the 4-stroke of a piston or 4-stroke of a engine. Okay. So for activity number 1, start the engine. What you're going to do is you have to fill in the table below. So we have the 4-stroke cycle here, the intake, the compression, the power, and exhaust. What you're going to do is to identify the movement of the piston in each stroke. So what happens on the piston during intake? Does it go down or does it go up? In compression stroke, does it go down or does it go up? In power stroke, what happens to the piston? Does it go down or does it go up? In the exhaust stroke, what happens to the piston? Does it go down or does it goes up? On the third column, what happened to the mixture of gases? So in intake stroke, what happens to the mixture of gases? So Meaning to say, the gases or the fuel mixture is being taken inside. In compression, what happens to the mixture of gases? From the word itself, it is compressed. So the mixture of gases is compressed. How about in the power or combustion stroke? What happens to the mixture of gases? So it becomes combusted or burned kasi there's the spark plug ignite the mixture of gas or the fuel mixture. So what happens to the mixture of gases? It was burned or it was combusted. How about the exhaust? What happens to the mixture of gases? The burned exhaust or the burned mixture of gases will become removed or exhausted. Guide question: how does the piston behave during intake stroke? What happens to the gas mixture? Number 2. What happens to the piston and gases during compression stroke? Number 3. What is the function of the spark plug? What is its effect to the gas mixture's temperature? Number 4. Describe the piston and gases during power stroke. And number 5. In the exhaust stroke, what happens to the piston and mixture of gases? Number 6. What do you think is the effect of these exhaust gases in the environment? And number 7. Can you consider the heat engine to be 100% efficient? Thermal efficiency. The thermal energy produced from the combustion of fuel-air mixture is transformed into mechanical energy which moves the car. So the thermal energy from the combusted fuel-air mixture will be the source of the heat engine to produce work and for the car to move. However, not all the thermal energy is converted into useful work. Hindi lahat ng thermal energy ay ma-convert sa work. Parts of the engine itself, the cooling water in the radiator and the surrounding air will absorb the heat and will not be available to perform work. Kasi yung ibang heat na galing dun sa thermal energy, yung iba dun mapupunta sa other parts of the engine. Yung iba doon mapupunta sa cooling water in the radiator at yung iba doon ay mapupunta sa surrounding air. At those heat will not be available to perform work. This thermal energy o yung init na hindi na-convert into useful work ay tinatawag na waste heat. These heat losses are unavoidable and greatly limit the efficiency of heat engine. So, hindi ma-avoid, hindi maiwasan yung pagkawala ng heat o yung mga heat na hindi nagamit para mag-perform ng work. For example, the engines of e-cars are only 30% efficient. Normally, lahat ng sasakyan, 30% lang efficiency niya. Ano ibig sabihin yun? Yung 100% na diesel na combust, sinunog, naging source ng heat. Yun ang gagamitin ngayon ni engine ng isang sasakyan para maging work. Pero 38% lang nung na-combust na init mula dun sa 100% ng diesel, yun lang ang magagamit ni vehicle. Okay? Para kay engine, para dun sa engine. Wherein, yung mula dun sa 38% ng engine, 33% lang talaga ang magagamit para umandar yung sasakyan at para dun sa mga ibang accessory ng sasakyan. At 5% mula dun sa 38% ng engine, okay, ay magagamit lang sa friction at radiation o dun sa radiated. And most of the heat that being combusted from the diesel, 24% lang nun ng 100% ay mapupunta sa coolant or cooling reservoir. At 33% will become exhaust gas o mapupunta sa environment. So, meaning to say, 70% ng heat na na-combust mula dun sa diesel ay naging waste heat lang. at 30% lang talaga ang nagamit ng sasakyan para mag-perform ng work. So this means that for every 100 joules of thermal energy produced by combustion of gasoline or diesel, only 30 joules are used to actually move the car. Therefore, it is impossible to construct a heat engine that is 100% efficient, which can fully convert all the heat into useful work. An engine that converts energy into more work and less waste is said to be more efficient. Kung isang engine, mako-convert niya halos lahat ng heat into work at less ang waste, ang engine na yun ay more efficient. But according to Sadi Carnot have found out that while it is true that we can express efficiency in terms of work, the efficiency of ideal heat engines depends only on the temperatures of the hot and cold reservoir. Sabi ni Carnot, although this statement is true that we can know the efficiency of a certain engine through in terms of the work, kung lahat ba ng heat ay halos lahat ba ng heat ay na-convert into work. So that's the efficiency, that engine is more efficient. Dagdag niya, the efficiency daw ng engine ay ideal if heat engine depends only on the temperature of the hot and cold reservoir. So, ang efficiency daw ng isang heat engine ay magdedepende lang at magdedepende rin sa temperature ng hot at ng cold reservoir ng engine. According to Sadi Carnot, an engine operating between two reservoirs of higher temperature difference is more efficient than an engine operating between reservoirs of nearly the same temperature. So meaning to say, if the heat engine has two reservoirs and the two reservoir has higher temperature differences, malayo ang agwat nila o malayo ang agwat ng kanilang temperatura sa isa't isa, that engine is more efficient kaysa doon sa isang engine na ang reservoir niya ng hot at cold ay medyo malapit ang diferensya ng temperature. The efficiency of a certain heat engine is calculated as efficiency is equal to work done divided by input heat times 100%. So para malaman natin ang efficiency o kung gaano ba kaganda yung isang heat engine, kung gaano niya ba nako-convert ang lahat ng heat into work. So we have the formula efficiency is equal to work done over the heat input times 100%. But since work is just the input heat minus the exhaust heat, the equation becomes efficiency is equal to QH minus QC over QH times 100%, or efficiency is equal to 1 minus QC over QH times 100%, wherein our QC here, sa QC, that's the energy removed by heat or the energy in cold reservoir. Ito yung mga energy na hindi na-convert into work. Okay, yun yung mga waste heat. Well, this QH is the energy added by heat. It is the energy that comes from the hot reservoir. The equation for efficiency can also be modified to use temperature measurements instead of energy values. So instead of energy values, we can know the efficiency of a heat engine using the temperature. So efficiency is equal to 1 minus TC over TH times 100%, wherein our TC here is the absolute temperature in cold reservoir. That's the temperature in the cold or the lower temperature reservoir. That's the TC. And the TH here is the absolute temperature in the hot reservoir. This is the temperature in the higher temperature reservoir. The temperature are the absolute temperature on Kelvin scale. So we are using the Kelvin scale in identifying the temperature of the cold and hot reservoir. So let us solve this sample problem. You see, let us by trying to get the efficiency of a certain heat engine in this problem. Number 1. What is the efficiency of a gasoline engine that receives 193 joules of energy from combustion and lose 125 joules by heat to exhaust during one cycle? So this is the energy received. So this will be your QH. The loose energy is the 125 joule. That will be your QC. Okay. So given your QC is 125 joules, that's the removed heat or the loose heat or your waste heat. Then the QH is the added heat, that's 193 joules. So we are looking for the efficiency. So to get the value of efficiency, our formula will be efficiency is equal to 1 minus QC over QH times 100%. Let us now use the formula. Let us substitute the value to the formula. Efficiency is equal to 1 minus QC is 125 joules divided by QH. The QH is 193 joules times 100%. So 125 joules divided by 193 joules, yun muna ang gawin natin. The value is 0.6477. Okay, tanggalin na natin yung joules kasi na-divide natin. So, therefore, efficiency is equal to 1 minus 0.6477 times 100%. Let us subtract this. So 1 minus 0.6477, the answer is 0.3523 times 100%. So the efficiency will be 35.23%. So that is the efficiency of the gasoline engine in this sample problem. For the second sample problem, suppose a steam engine receives steam at 600 Kelvin. The engine uses a part of this thermal energy for work. It exhausts the rest to a condenser at a temperature of 350 Kelvin. What is the maximum efficiency of this steam engine? So in this problem, instead of the heat or the energy, it uses the temperature. Okay. So therefore, our TH here is 600 Kelvin. That's the temperature on the hot reservoir. The TC here, our TC will be, or the cold temperature, or the temperature from the cold reservoir is 350 K. So, per Kelvin. So, the given are TC, that's 350 Kelvin, and TH is the 600 Kelvin. We are looking for the efficiency. So to get the value of efficiency is equal to 1 minus TC over TH times 100%. So let us now substitute this value to the formula. So 1 minus the value of TC is 350 Kelvin over TH. The value of TH is 600 Kelvin times 100%. So let us first divide 350 Kelvin to 600 Kelvin. So 350 Kelvin divided by 600 Kelvin, the answer is 0.5833. Okay, so now 1 minus 0.5833 times 100%. Let us first subtract it. So 1 minus 0.5833, the answer is 0.4167 times 100%. The efficiency of the steam engine here is 41.67%. So for activity 2, problem solving, which is equivalent to 20 points, solve the following problems on efficiency. 20 points. First problem, a hot gas is injected into an engine at 573 Kelvin and exhausts at 343 Kelvin. What is the highest efficiency of this engine? Number 2, What is the efficiency of the gasoline engine that receives 185 joules of energy from combustion and lose 130 joules by heat to exhaust during one cycle?
3, 2, 1.
Short quiz, multiple choice, write only the letter of the correct answer, 1 point each, equivalent for 5 points. Number 1. Which is the correct sequence of the 4-stroke cycle? Letter A, intake, compression, power, and exhaust stroke. Letter B, power, intake, exhaust, and compression stroke. Letter C, compression, power, intake, and exhaust stroke. And letter D, power, compression, intake, and exhaust stroke. Number 2. What is the function of heat engine? Letter A, it converts chemical energy to mechanical energy. Letter B, it converts thermal energy to mechanical energy. Letter C, it converts mechanical energy to chemical energy. And letter D, it converts thermal energy to chemical energy. Number 3. What is heat engine? Number 3. Why is heat engine not 100% efficient? Letter A, because all mixture of gases is converted into work. Letter B, because engine needs to be cooled down. Letter C, all the gases are used up by the engine. And letter D, some of the gases is taken up in the piston. Number 4. What causes thermal energy? Letter A, exhaust of different vehicles. Letter B, exhaust from different industrial engines. Letter C, exhaust gases into the environment. D, all of them. Then number 5, what is the function of the spark plug? Letter A, the spark plug ignites the mixture making it temperature high. Letter B, the spark plug pushes the piston down. Letter C, the spark plug pushes the piston up. And letter D, the spark plug pushes the gases out of the cylinder. Right, for your week 7, you have to answer, don't forget to answer activity 1, activity 2, and the short quiz. Total points is 40 points. Good luck. Thank you for watching and listening. Have a nice day.